these are answers to review sheet E. We're converting between degrees and radians here. What you need to remember is that pi radians is the same as 180 degrees. And if I want to end up in radians, I put my radian measure on the top, so pi over 180, and I multiply it by the angle that I'm changing, so this time 30. Pi over 180 times by 30, if I cancel that down, my answer is pi over 6. This second one, part B, is one that you should remember off the top of your head really, because you know that pi radians is the same as 180 degrees and 90 degrees is half of 180 degrees. So in radians this is pi over 2. If you don't remember that, you just want to learn the rule, if we're ending up in radians, then it's pi over 180 times by the degrees that I'm changing. If I cancel that down, I get the answer pi over 2. See then, exactly the same method. I want to end up in radians. Because I want to end up in radians, do pi over 180 and times it by the angle of 20. If I cancel this down, my answer is pi over 9. I won't do D and E because they follow the same pattern. In this second question, I'm reversing the process. So now I want to end up in degrees. So instead of pi over 180, I'm going to have 180 over pi. So here on the top, I'm going to have whatever I want to end up in. So degrees, so 180 over pi times by pi gives me 180 degrees. It's for part A. For part B, want to end up in degrees, so 180 divided by pi and then times by 2 pi gives me 360 degrees. For question 3, you'll need your calculator again. So I'm trying to find sine x. So that tells me x is sine minus 1, 0.6. Put this in your calculator, you'll come out with a value 0.64. But what I actually want to find is the solutions between 0 and 2 pi. So I need to find my second solution. In order to do this, if you use the help sheet on the front of your review sheets, see that the second solution here for sine is found by doing pi take away the first solution. So using sine pi take away the first solution, putting that into my calculator, I get a second value of 2.5. Part B is cos and works in exactly the same way. So I'm trying to find x. So to start with, I'm going to divide 0.2 by 2. I've taken this 2 over to the other side. This gives me cos x is 0.1. So now I use my calculator, because cos to the minus 1, 0.1. Putting this value into the calculator, I get a value 1.47. At this point, as soon as I do cos to the minus 1, that's when I need to find my second solution. So using my little cheat sheet down here, I know that cos for my second solution is 2 pi take away the first solution. So my second solution over here will be x is 2 pi take away 1.47, giving me an answer of 4.81. So my two solutions are here and here. So part C has got an extra step built in. I start off in exactly the same way. So pi x all over 2 equals cos to the minus 1 of 0. Now as soon as I do inverse cos, that's the point I need to find my second solution. So if I just put it into the calculator, my first solution is pi over 2. But I must straight away do my second solution. So pi x over 2, so that's just this part repeated, equals my second solution 2 pi take away my first solution, which was pi over 2. Now I've got two separate equations here and here, and I need to solve both of them. Now you can just put this into your calculator if you'd like to, but if we look at this, both sides have got 2, so I can just cancel those out, and both sides have got pi, so they can cancel also. This side then I'm left with just x, and on the other side 1. My first solution is x equals 1. On this side I need to do a little bit more work. So pi x over 2, that side of the equation, equals 2 pi take away pi over 2 is 3 pi over 2. Now I can do the same thing, cancel the things that are on both sides. My second solution here gives me x equals 3. Part D, using your calculator, pi x over 4 is sine of the minus 1 of 0.5. Gives me pi x over 4 equals minus 1 over 6 pi. Remember, it's as soon as you do inverse sine that you need to find your second solution. Our second solution for a sine is pi take away the first solution. So I start off with what I've got here, pi x over 4 equals pi take away my first solution, which was minus 1/6 pi. Now I've got two equations to solve. The first one is nice and simple for me. I can cross off the pi, as that's on both sides. Rearranging for x gives me x equals minus we should spot a problem here. This value is not between the range that I've been asked for, so it's not between 0 and 2 pi, so this answer is no good to us, and we're going to reject that answer. Going back to our second solution now, give me pi x over 4 is equal to 7 over 6 pi. Cancel the pi's from both sides, and I'm left with, when I rearrange it, x is 14 over 3, and this is a solution that we want. Let's consider for a second what what a sine wave actually looks like. Oops. Here we go, this should go through 0, so I'm going to rub that out, just calibrate the board so we can get it looking correct. Okay, that looks better. So what you've got to remember is that also we could continue drawing this side. So when we've used our calculator and we've got this solution here, that's given us a solution before the 0. But for this value going along, I can see I still have 2 others in the range. This one I've found over here, and so I need to calculate this one. We can see that between this point that the calculator gave us and this point here is going to be 2 pi. So I can take the answer that I got from the calculator and just move it on to pi. If I do that, I get 11 pi over 6. So I need to use this here. Pi x over 4 equals 11 pi over 6. Cancelling out the pi's gives me x equals 22 over 3. So a little bit tricky, that last part. Question 4a wants us to find the maximum value of h and when it occurs. We need to look at this part just here, sine t. Think of our sine wave. What's the maximum value that the sine wave can be? It's 1. So for h to be a maximum, sine t needs to be at its maximum. So h equals 2, and I can replace the sine t by its maximum value of 1, take away 1. My h is 2, take away 1, 1. So the maximum value is 1. It also asks, when does this happen? Well, it happens when sine t equals 1. So I can now use my calculator to sine to the minus 1 of 1 to get a solution of pi over 2. I could have observed that from looking at this point in the sine wave also. Question 4b, same again, wants to know the maximum value of y. So I need to consider this section here, cos pi t over 2. It doesn't really matter what comes after the cos. If I just consider my cos wave, what's the maximum value that this can have? Its maximum value is 1. So this part just here can be replaced by 1. So y equals 4 times by 1 plus 2, giving me 6. So the maximum value of y is 6. When does this happen? Well, it happens when cos pi t over 2 is equal to 1. If I use my calculator to get a solution for cos to the minus 1 of 1, I'll end up with an equation pi t over 2 equals 0. Remembering what we did in the earlier parts, as soon as I do inverse cos or inverse sine, that's when I need to do my second solution. So I've got pi t over 2 just from here, same for this one. And for my second solution then, Remember what it was for the second solution of trig, because it's 2 pi, take away your first value, so I'll end up with 2 pi, because 2 pi take away 0 is 2 pi. So back to my first solution, and I get a value t equals 0. So that's my first solution. And here I'll get a second solution. I can cancel out pi from both sides, rearrange to get t equals 4. I have two solutions.